Hello everybody. In this short video concentrating on our software or app Speech Articulation Trainer version 4. In this video I want to concentrate on the articulatory model, which is in the center of this app. The articulatory model used here is based on static MRI data of one speaker, and I've published that on my web page speechtrainer.eu, not edu, speechtrainer.eu, which means speechtrainer.europe, EU. So, and on this website around 2000 I have written some papers concerning the construction of this model. So how is the model controlled? It is controlled by control parameters, which is the main menu values here. Going to the main menu values, we see we have differentiated this parameters or these values shown here for each sound up to more important parameters controlling vowels, which are the vocalic parameters, and parameters controlling the consonantal constrictions. So we again focus on the vocalic parameters. So our model has just very few model parameters, and so we just differentiate vowel height, which, as we can see here, for vowel height it does a lot. It not just controls the shape and the location of the tongue body position, but as well the jaw position, as well the larynx position. Okay, so we can change vowel height, we can change vowel back front position, and as we know from our basic phonetic knowledge, is that in addition we can control lip rounding. Yeah, and these parameters vary in case of the vowels mainly. Then we have the parameter which is as well, these three are as well important for consonants. We have the velum, very strongly clothing the velopharyngeal port if we have values above, let's say, 200. Yeah, in this case we have non-nasalized consonants, and we can open it for producing nasalized consonants and nasalized vowels, at least nasalized sounds. The next parameter is the glottal opening, which varies as well from wide opening, breathing, that is this arrow going to a smaller but still an opening which is wider than which is relatively wide, but now frication is generated, going to a lower degree of opening. More or less the vocal folds are closed now, but not tightly closed. Then we have phonation. In between there is this phonation in combination with aspiration, so breezy voice, ah. Then we have normal phonation, ah, and then we can go further to negative values, which models the glottis stop. Okay, the last but not least parameter is glottal pressure, which needs to be positive in order to be able for phonation as well as for aspiration and so on. So we need a positive value here. So now going on to the consonantal parameters. So we choose a mean position for the tongue body and unrounded vowels in this case. So now going to the consonantal parameters, we can model a labial constriction, and we can differentiate between full closure, which is a plosive, and a fricative closure, which in our case is directly combined with changing the position of the articulator from bilabial to labiodental. In some languages, I have to model as well a bilabial fricative. I will implement this in addition in later versions of the model. So full to fricative. In the case of the tongue tip, again, full closure, which means the tongue is not grooved in the middle. It is a full aerodynamic closure. There we can not send any airstream through this constriction. We can have a fricational closure, which is not seen in this mid-sagittal view, but that this arrow means we can generate fricational noise here by having a mid-sagittal groove within the tongue, which is beyond our possibilities in modeling this in a 2D dimensional model. We perhaps later give some more views concerning the model and include this. And in the case of this closure here, we can as well model a lateral opening, so only a mid-sagittal closure, which occurs in the case of an L, a lateral. Okay, and at least we can change, which is important in the case of fricative, the location. Please see the video, so the concrete location of the apical closure. See my video on fricatives for more details on this. And last but not least, we have the dorsal full closure, which in most languages occurs here more velar than palatal. Even if we change the front-back position, it stays in the form of the velar closure. But if we choose, in this case, a fricational closure here, which occurs in some languages like German, we have the ich and ach sound, which this would be an ach sound. And now if we change this, this parameter for the location of the closure, we can differentiate between the ich, so the palatal tongue body closure, and the ach sound, which is the velar tongue dorsum closure. Yeah, that's the most I would like to tell you on the model. Thank you very much so far.